Imagine floating right outside the International Space Station. The sun is shining directly at you, burning at millions of degrees. Yet, the space around you is unimaginably freezing, almost at absolute zero. Have you ever stopped to wonder why? Our sun releases more energy in a single second than humanity has ever used in its entire history. It lights up billions of miles of the solar system. So why in the middle of all that fire is deep space so incredibly cold? This is one of the greatest contradictions of the universe. And the answer will completely change how you look at the night sky. To solve this mystery, we first need to unlearn everything we think we know about what hot and cold actually mean. Down here on Earth, we think of temperature as the air around us. But in physics, temperature is not a property of empty space. It is a property of matter. It measures how fast tiny particles are moving and vibrating. A hot cup of coffee just has particles jiggling furiously. A solid block of ice has particles barely moving at all. If you keep cooling something down, you reach a theoretical limit called absolute zero, where all atomic movement completely stops. But here is the mind-bending part. If there are no particles, you cannot measure temperature. You literally cannot measure the temperature of nothing. And space? Space is a massive vacuum. A cubic meter of air on Earth has billions of molecules, but in deep space, it might have just one single atom. Because space is empty, heat has a very hard time traveling. In the universe, heat moves in three ways. First is conduction. When you touch a hot pan, heat flows directly into your hand. But in space, objects aren't touching, so conduction is impossible. Second is convection. This is how hot air rises and cold air sinks, carrying heat through a fluid or gas. Space has no air and no oceans, so convection doesn't exist out there either. That leaves the third and final way, radiation. Heat can travel as electromagnetic waves, like light, completely invisible and fast. This is the only way the sun's massive energy crosses 93 million miles of empty darkness to reach our planet. But here is the twist that tricks everyone. Thermal radiation does not heat up the empty vacuum it travels through. It only creates heat when it physically crashes into something with mass. Imagine shining a flashlight in a dark, dusty room. You only see the beam where it hits the dust or the wall. The sun's energy is exactly the same. It fires invisible waves of heat constantly, but those waves just pass right through the empty vacuum. Space itself doesn't absorb the heat because there is literally nothing there to catch it. Space isn't cold because the sun is far away. Space is cold because it is empty. Only when that radiation hits a rock, a planet, or an astronaut does it finally turn into warmth. Because of this, space presents the most brutal environment imaginable. Without air to act like a blanket and spread the heat around, you get terrifying extremes. If you are an astronaut floating in direct sunlight, the front of your spacesuit can heat up to 250 degrees Fahrenheit, hotter than boiling water. But just a few inches away, on the shaded back of your suit, the temperature plunges to minus 250 degrees. You are literally boiling and freezing at the exact same time. The moon experiences this every single day. Stand in the sunlight on the lunar surface, and you will roast. Take one step into the dark shadow of a crater, and you will instantly freeze. There is no middle ground. If you want to see how crazy this physics gets, look at NASA's Parker Solar Probe. This is the closest any human-made object has ever flown to the sun. It literally touched the sun's outer atmosphere. The front heat shield faced a blazing inferno of 2,500 degrees Fahrenheit, hot enough to instantly melt steel. Yet, right behind that thin shield, the spacecraft's delicate scientific instruments were chilling at a freezing minus 230 degrees. This wasn't a glitch. It was perfect physics. The shield took the direct hit of the radiation, and because the vacuum of space behind the shield cannot conduct heat, the rest of the ship stayed completely frozen. Move an inch into the shadow, and you go from inferno to a deep freeze. So, if the vacuum can't hold heat, is space perfectly at absolute zero? Actually, no. The universe isn't entirely empty. There's a faint, invisible glow of ancient energy filling every corner of the cosmos, left over from the Big Bang itself. It's called the cosmic microwave background. This ancient energy keeps the baseline temperature of the universe at roughly minus 455 degrees Fahrenheit, just barely above absolute zero. Because the universe is constantly expanding, it's actually getting colder every single day. There's even a place called the Boomerang Nebula, a rapidly expanding cloud of gas that is minus 457 degrees. It is the coldest known natural place in the universe, even colder than the empty space around it. This rule of space explains the weirdest paradox in our solar system. Mercury is the closest planet to the sun, so it should be the hottest, right? Wrong. While its days are blazing, it has no atmosphere. So at night, all that heat just bleeds back into the cold vacuum, dropping to minus 290 degrees. Venus, the second planet, is actually much hotter, not because it's closer, but because it has a thick, toxic atmosphere that traps the sun's radiation like a giant greenhouse. The rule is simple. Without an atmosphere to catch and keep the heat, the warmth of a star is useless. You need a blanket. And that brings us to the most mind-blowing realization of all, our home. The warm, comfortable breeze you felt today is not the normal state of the universe. It is a 1 in a billion cosmic miracle. We live on a rare rock, sitting at the exact right distance from a star, wrapped in a perfect atmospheric blanket that catches the sun's radiation, spreads around, and protects us from the brutal extremes of the void. Without it, Earth would just be another dead, frozen rock like the moon. The universe is mostly an endless, unimaginably cold ocean of darkness, dotted with a few tiny islands of warmth. If this journey through the cosmos blew your mind, drop a like, hit that subscribe button, and turn on notifications so you don't miss our next deep dive into the unknown.